Okay guys, shh. 5. A boy consists of an inverted cone on top of a hemisphere. The radius of the hemisphere is 6 centimeters. The height of the cone is 9.1. Assuming pi to be 3.14, find the volume of the boy. Now to find the volume of the boy, it's just volume of a cone plus volume of a hemisphere. Now when you go to your notes, what you're going to find out is there's no volume of hemisphere. There's only the volume of a sphere. Volume of a sphere is 4/3 pi r cubed. How would you turn that into a hemisphere? Half it. When you half it, the 4/3 turns into 2/3. Okay, so that's the volume of a hemisphere. Okay. Now, next thing is volume of a cone. We already know the volume of a cone is 1/3 pi r squared h. The volume of a hemisphere is 2/3 pi r cubed. Basically what we got to do is just enter all the figures into the calculator. So we're going to get 1/3, 3.14, r squared being 6 squared, h being 9.1, plus 2/3, 3.14, radius cubed is 6 cubed. If some of you could do that in the calculator, that'd be brilliant. If not, I'll try and beat you there. Yeah.
Everything has to be competitive.
Okay, 1/3 multiplied by 3.14. Oop, I'm really not doing great on this one today. 3.14 times 6 squared, 9.1. I made a mistake there again. 9.1. Plus, do it all in one go, 2/3, and then 3.14 times 6 cubed. Okay, just check this answer out with me. I got 795.0554. Is that what you got? Okay. Let's round that off to 79505. Okay, is it centimeters cubed or centimeters squared? Cubed. Now, here's the hard one. Okay, once we have that one done, the next thing we got to do is find out the surface area. Okay, now because this object is closed, you know what I'm trying to say? What I mean by closed object? I'll show you now. Do you remember the circle we used to add on to both of them? This part here. That is contained within the object. Therefore, you're not going to be using any circles. You're just going to be using the curved surface area of the cone and the curved surface area of a hemisphere. You go to your notes for a sphere, and what you'll notice is you're going to get this 4 pi. What's it? 4 pi r squared for the area of a sphere. How would you get the area of half that? 2 pi r squared for the hemi. Okay? The area of the hemi. Now, the one thing you got to remember, okay, I'm also going to do this now while we're here. If you have a sphere, okay, and you cut the hemisphere in half, what happens is you usually end up exposing a circle on the bottom that you have to add on, but because it's enclosed with the cone, you don't have to worry about that circle. Okay, now that that's done, what we got to do next is we got to find out what formula we're using for the area of the cone. What's the surface area of a cone, lads? Surface area of a cone? Pi r L. Big problem here is, what is L? Shh, lads. L we have to get in Pythagoras' theorem. L squared equals h squared plus r squared. L squared equals what's it? 9.1 squared. Will somebody do 9.1 squared plus 6 squared and square root it? Plus 6 squared. Okay, that's that answer there. We're going to square root the answer, and when we square root the answer, we get 10.9. We're expecting something like 10.9, aren't we? Because L has to be the longest side. 10.9. Okay? Now that this is done, let's put these two answers together. We're looking for 2 pi r squared plus pi r l. So what we're going to get is 2, does it tell us to use pi as anything? 3.14. What's the radius? Anybody radius? 6 squared plus pi, sorry not pi, 3.14. 3.14, 6 squared. 3.14, no, not 6 squared, just 6. And what's L? 10.9. All of that into the calculator in one go. How does that come out? So yeah, good point. 2 times 3.14, that's the start of it, okay? And then 6 squared. Plus 3.14 times 6 times 10.9. Close it. 431.43, is that what we got? Yeah. So 431.44, okay. Centimeters squared. How would you write that question? Doable enough, okay? Next one. Number 9, okay? The dimensions of a gable end of a garage, right? So it's obviously, anyways, right? So what's going to happen here is we have 2 different areas. We have the red area. That's the red area is basically the rectangle. The blue area being the triangle. It goes find the exterior area of the gable end. Includes the middle part because you can see nothing about how to get the area of the wall. So the area of the wall is obviously not included. They're talking about that this full thing is like a garage door. Okay? So what we got to do is, how do you find the area of the triangle? Can anybody tell me the triangle? Now, the triangle's a difficult one.
That's easy.
We usually go for half base by height, wouldn't we?
Yeah.
Now, why? Shh, that's an important one. Okay? Why can't we go for a half base by height?
There's no degree angle.
We don't know the height, and there's no way of getting the height. That's the problem. We got to do the S formula. Now, what do we know about the length of this one?
No.
It's also 2.5 because it has this symbol here to say that's 2.5. Now, guys, what's the S formula again? Is that the very first exercise we did? I think it's 8. Just please check this for me.
No, it's over 2.
Over 2, and then the area is
square root S bracket S plus A.
S minus A.
S minus A. S
Minus B. S minus C. Yes, Jack. You could do Pythagoras as well. You're right. Now, lads, that's one way to do it. But what we're trying to say there is that the S is a big commitment. We can do it that way. We can get it out, no bother. A is 2.5. Sorry, lads, Ken. A is 2.5. B is 2.5, and S is 4. We can get it out that way, no bother. If you don't see it. But what Jack's saying makes perfect sense, right? What Jack is saying is, why don't we half the 4 to get 2? And then we have we can use this triangle here as a 90-degree triangle, okay? And when it's a 90-degree triangle, all you have to do to get the perpendicular height is basically, it's going to be 2 squared, and this is going to be 2.5, and we have to find out what x is, okay? So let's do it that way. It'll be shorter than the ABC method anyway. So, but just to let you know, there is an option if you don't find it. Okay? So lads, 2.5 squared equals x squared plus 2 squared. Shh. Okay? Okay? 2.5 squared equals 5.25 or 6.25. And what are we going to do with this 2 squared? What are we going to do with that? We're going to bring it over to the other side. So it's going to be minus 4 equals x squared. And then we're going to get x squared equals 2.25. Pretty sure when I square root that I'm going to get 1.5. Okay, 1.5 or 3 over 2. So look, x equals 1.5. Now we know the height. Okay? the height is going to be 1.5 and the base is 4. It's 1.5 and 4. Okay? Now, we know this is for the this part here. 1.5 and 4. A half base by height. So a half base by height is a half 4 times 1.5. And what do we get there? 3 meters squared. Finally, that leaves the easy part now. The easy part being the rectangle, okay? What's the height of the rectangle, Jack? Just the height of the rectangle. The rectangular part of the garage.
3 meters.
Sorry? 3 meters, is it? And the width is? 4 meters. Multiply them by each other. 12 meters squared. 12 plus 3. 15. The full thing is 15. The triangle is 3 meters squared. The rectangle is 12 meters squared. Add them together, you get 15 meters squared. Go back to the top. Now, this whole thing here, don't have to worry about anything else now. The whole thing is 15 meters squared. It tells us that the length of the garage is 8.25. So if I was to do something like, if I was to draw something like that, and you can see that's basically what they're looking at. It's just a 3-dimensional image. It's basically, do you want me to find the volume, okay? So all we've got to do is multiply my area by the length. Remember you did that a while back. Anytime you get the area of the face, multiply it by the length. So just multiply it by 8.25. And what's the answer to that one? 123.75 meters cubed this time, okay? So lads,